So this is Atomicals. This is digital matter organization. This is a comprehensive solution to organizing digital objects. We call it digital matter, like bitmaps is digital matter theory. You may have heard that being talked about. We have ordinals, we have naming systems, we have all kinds of new protocols emerging. And this is Atomicals to help complement and build on top of what exists. First, I'd like to talk about what are the main problems that Bitcoin creators face to really understand what we're trying to do here. I'm going to go quick because we have so many slides, so many things to cover, and I want to leave enough time for questions at the end. So the main problems are there's proprietary APIs, which lead into vendor lock-in, over-reliance on proprietary APIs. It costs a lot for developers, and there's different views of on-chain data. This causes significant problems for developers who want to innovate because they're trying to decide what APIs to use, and they're all different in their own little ways. Unreliable indexing. This, significant values of assets are being put onto ordinals on Bitcoin, and with unreliable indexing, we don't really know if you're going to get an ordinal number that's positive or negative, for example. That's one of the things that came out of one of the edge cases that was discovered. It's difficult to compose and build on top because there's just so many changes and the building blocks are just rather low level, which is great to have gotten started with inscriptions and to be able to bootstrap this entire economy. But we really need something more because there's a lack of higher order structure right now. Okay. So there's also limited on-chain metadata. So for example, collections must be manually uploaded on GitHub and they must be updated across dozens of marketplaces and hope that there was no error in the process. Very expensive to fix errors. And the structure of ordinals leans very heavily to a single file usage, which means there's off-chain conventions and proprietary indexing conventions by different marketplaces. This leads to less control for creators because without an access to a robust high-performance indexer, then we end up depending on marketplaces and the services that are offered by these proprietary walled gardens. Less profit, of course, because then we're over-reliant on specific services and marketplaces and their indexers, their APIs, their wallets. Okay, so what are Atomicals? Well, Atomicals is the simplest, most flexible way to create and organize digital objects, digital matter. So we're standing on the shoulders of giants, complementing and organizing all the data I mentioned earlier, ordinals, bitmap, the ERC20, and of course Atomicals, because Atomicals is a fully standalone protocol, but also complements what exists and what will exist in the future. But why Atomicals? To permanently take back control over our digital sovereignty and solidify Bitcoin as the main proof of work beacon. Bitcoin is a revolution for freedom and sovereignty. And Atomicals is going to help put tremendous value on the chain and further solidify the main proof of work signal that we have on planet Earth as the main primary proof of work blockchain. The agenda for today, quickly, is we're going to introduce the theory. We're going to introduce Bitwork, which is mineable tokens, containers, which is just another name for a collection standard, and so much more, and ERC20, which is Satoshi Faithful Colored Coins. Let's begin. So a digital object, or atoms, are basically NFTs encoded in the familiar fashion to ordinals, except with the simplest possible rules that can work, treating the UTXO as a colored coin. There's multiple file support using the CBOR format, which of course is basically JSON compatible. So you can have an image.jpg in an Atomical, you can have a metadata.json in that same Atomical, and you can have any other key value data during the mint and later. That's the immutable state. So upon mint, we can always refer back like a digital artifact. We have the images, the PDF, video, any document has an immutable state that's burned permanently on that transaction. Then there's dynamic state. This is where we depart. Is each transaction, each transfer allows data to be updated. It's a key value store. You can update files, update any kind of data. It's just an object. We have things like freezable properties. So you can lock a property. You might have, let's say in a game, you might want to lock some scene or some weapon is not able to be used until some future point in time. You can lock a property and to a certain block height. So everyone else has to converge on the same consensus for that property having a certain state and a certain value until a certain future point in time. You can also have immutable properties, which once set, they're set forever. We'll talk about this later when we get to containers, why that's useful. We have an event feed. Every Atomical can publish its own event feed. You can have your own Twitter feed or social network built on an NFT. If the NFT is your profile, you can have a feed that other indexers, other services can just follow and trace through all the things that are happening for that token. It doesn't just have to be in social use cases. Anywhere there's a stream of data that you're interested in, we can now synchronize on planet Earth. Parent-child relationships. We can have any number of parents, 0 to any number, that must be spent as inputs. So you can create complex chains of dependencies by including other Atomicals as required inputs to be able to have the mint succeed. Okay. Well, the use cases I just mentioned here, we have things, everything can be tokenized. Community is token, web profiles, websites as token. Any file, any collection of files can be tokenized. Okay. I'm going to demonstrate, well, this is pre-recorded, but here's a demonstration in 20 seconds how to create a fresh wallet and mint an NFT image in about 20 seconds. Here we're going to mint the Bitcoin logo, bitcoin.png. We're going to create a wallet.in with the command line and issue the mint. A QR code is presented, expecting payment. Once the payment goes through, the transaction, the reveal transaction, sorry, the commit and the reveal transaction are made, and you've minted the NFT in about 20 seconds from scratch with no prior wallet, no prior anything. Okay. And so you can see here how easy it is to create an NFT and start from scratch. The regular person can get going in literally 20 seconds. To get the latest feed of Atomicals, we just go CLI list. You get a list right here. You can see here some important details is that we have something called an Atomicals block tip. So we introduced the concept of an Atomicals block header, block hash. So each Bitcoin block is taken and concatenated with all the Atomicals transactions in the block, and we create a Atomicals block hash. And so you'll see that this is useful for synchronizing across indexers, because as long as the Atomicals hash matches for the current block, then we know that everyone has the same snapshot of the data. So that's one thing you see here. We see the atomical count of minted 1. So there's an atomical count of 1. The first is the atomical number 0, and we can see there's this atomical ref that is also the atomical ID. And so in this scenario, we can see that we'd be able to get a feed of the Atomicals and display them for in the terminal here. And here's the image data you can see of the Bitcoin Bitcoin PNG. Okay, moving on. And to update the dynamic data, so I mentioned there's a key value store. Let's go and update some data and see what that looks like. Okay, so we have here the set command. We take the atomical ID, which can be an alias or other things later on, but we'll just take the atomical ID, set a path name, and then the key value hello world, and we'll make a lucky number 777. And this is what it looks like to update on the command line. QR code is displayed. and we make a payment to do the update. Okay, just give it a moment to see. Okay, and you see here that once the payment goes through, everything's fully automated to update that Atomical with the data. Once it's confirmed, we're going to see that the data is updated. And here it is after we query, after it's been confirmed. We get the state using the CLI state command. We can see that for the namespace called path name, we have the latest snapshot. The hello value, the hello key has the value world. We can see the transaction ID, the height, even the transaction number in the global Bitcoin blockchain where it was updated. Yeah, there's a lucky number right there, value 777, and then once again the path is repeated to show that the path was just updated recently. So to update the data again, we can now issue another set command to the same path. We update our lucky number to 888. And we set something called a permanent immutable property with the caret, the arrow that's pointing up. Once we set any property with the caret, it's locked forever, like forever. So it must be used with care, but it could be really useful if you have an Atomical where you want to attach maybe artist signatures, or maybe you want to make it a member of a collection or container later on. I know I'm getting ahead of myself. And then you can lock it to that container forever. So even if it gets transferred and updated later on, this permanent property, well, it remains exactly fixed. And we have this lockable property. So anything with the @ sign and then a colon and then the block number is one of those lockable properties or freezable properties that will be frozen until that future block height. So we can achieve consensus on that. And here it is after it's confirmed. You can see lucky number was updated because it is a dynamic property that can be updated. And then we have the permanent property. So even if you try to update that permanent property, it's the convention is no, it's ignored. And lockable property, of course, cannot be updated until the freeze time is over. You might not know when you want to freeze a property. It could be like a game or rounds in some match or some social game. And you could just define the freezable property up front with the @ sign and not provide a block height. And you can update it like a normal dynamic property. But then when you're ready, you could lock it to a future block height. Okay, now we're going to shift gears to Bitwork. That was what I just explained, was kind of the very quick tour of how to mint and create and update the base Atomicals. Now we're going to talk about Bitwork, which we're going to use to build on the next things. Okay, so Bitwork is proof of work, can be used for any Atomical mint. We can set a vanity transaction ID using the arguments with the Bitwork C parameter. It's basically saying what we want the prefix of the transaction ID to be, and it allows us to prove that energy was burned in the process of creating that Atomical mint. We can choose like a 1-letter prefix to many letters, and we'll see what that looks like next. The use cases, of course, for this are introduce an element of randomness into mints. We can organize communities around vanity TXIDs and refs, and of course, it's just bragging rights if you have a really cool ref or prefix that resonates with your community. We can do content ranking based on the costly signal theory. So we could rank content based on how much energy, provable energy, was burned. So remember that event feed I talked about before? Well, you could have profiles that are interacting, publishing, social posts, and we could upvote them with provable energy burn, or even inject the demand energy to be burned to mint them in the first place, and then rank everything trustlessly. Throttle and limit token mints. It works as a spam filter, of course. This is the original hash cache paper by Back, and one of the ingredients of the Bitcoin proof of work system. So we turn every token now into something that can be mined. So here's an example. Let's get to it. Bitwork. We want to mine, let's say, the ref prefix of cat, or the TXID prefix of 62B4, which encoded in Crockford base 32 is cat, C-A-T. Let's see what that looks like. We do a regular mint NFT. In this case, the atomical is just hello equals meow, and we set the bitwork flag to cat. It presents the QR code to make the payment. And then once that's paid, the mining process starts until all client side, by the way. None of this there's no proprietary servers. This is all done client side, local, and interacting with the open source indexer that we'll talk about later. So once the payment's made, we're going to see how the mining looks. Here it goes. Okay, so now your computer would be searching for the prefix of cat at this difficulty level of 4 hex digits. It's about a minute or two. And you can see here some estimates of if you have a longer prefix of how long it would take. You can go out as far as you want. And it is our hope that GPU mineable tokens are going to merge. Someone just needs to take the library of the CPU miner that I've written here and port it to GPU mining, and we can achieve much, much larger prefixes. Okay. So in this case, you see the prefix was found, it broadcasted the transaction and created it. And here's a screenshot of still for what happened. So bitwork matches the TXID, broadcasts the atomical ID is the commit TXID, not the reveal like Atomical Ordinals. There's reasons for this later. I'll talk about why Atomicals uses the commit transaction ID as the identifier for the Atomicals. There's a very important reason for this. Okay, but you can see here, once the token has been mined, we query the feed, and we can see that atomical number 1 has this transaction ID starting with 62B4, and it has the atomical ref when it's encoded as Crockford base 32. It has cat at the beginning. Okay, so this is an example of what it takes to mine. You'll see the bitwork parameter on the atomical is set. If you look below, it says bitwork C, which stands for bitwork commit, and bitwork R stands for reveal. So you can also add proof of work to the reveal transaction. In this case, it's set to null because we did not add proof of work to the reveal transaction, just the commit, because we wanted that really cool vanity TX of cat. That's why we did it. Okay. Moving forward, building upon bitwork and what we've done so far, we introduce a collection standard called containers. It's an on-chain collection standard, organize anything, atomicals, ordinals, bitmaps, everything and anything, add, update, delete items all in one go or incrementally, and permanently sealable. So once a container is sealed, it can never be changed. The UTXO is effectively burned, and there's a snapshot in time with the latest state as it was when it was sealed. You can imagine artists and collaborators attaching their signatures or their messages at the end when they finally created the collection to kind of sign off or give their autograph to the collection, and it's sealed permanently into Bitcoin land forever, untamperable. Well, a collection standard gives us the opportunity to have on-chain metadata. So we have all the items are in a standard format. We don't have to go to any other marketplaces or proprietary service to update a file and then hope they make the updates without error. No, we have an on-chain standard. It's done. Everyone gets the same data replicated. But that wouldn't be enough. We need a container name service. So everyone agrees on the name for the collection. It's a globally unique names identified by hashtag. First is first. In order to prevent name grabs and squatting, we must use bitwork. At least 3 letters to slow down the container name registration. So someone could not just easily register thousands of these container names. They're going to need to spend significant CPU time. Oh, at least 3 letters per mint to claim a name. And they have to be the first, of course, to do it and pay the on-chain transaction fee. Examples would be like Bitcoin Funks or Gemini Warriors. You can really be any name up to 64 characters long, as long as it doesn't include things like emojis and all that. But any readable container name is up for grabs. First is first. Okay, that's how the container name service works. So let's do a mint and claim of a container name and see what that looks like. So we mint-container, we call it my cool container, and we set the bitwork to just MYC, just because. We can use a hex prefix, but we can make it anything. We'll just use this for a demo. Here we go. It's waiting for the payment, and it's going to mine the Bitwork prefix. That's their spam filter. That's our throttling mechanism. And once the user successfully mines the prefix, the container will be in the registration process. I'm going to talk about next what that means. Okay, let's just watch this go through. And here, I just sped it up. Here's what happens after the container is minted, and we query the Atomical. We can see here that the container is pending candidate. So the Atomical is the leading candidate for the container. We must wait 3 blocks after commit to achieve confirmation. Now, let me explain what this is. In order to have a robust identity name system, we have to solve for front running. We can't have a system where some adversary could just monitor the mempool to see all the interesting names, like container names being taken, monitor the mempool, and then front run all the cool collection names, and then mine those names themselves while they're monitoring the mempool. We can't have a system that allows front running. It just won't work at scale. It's not workable long term. So what we do, remember I said that the commit ID is used as the Atomical ID? That's why. We actually use the Atomical ID, the commit ID, as authoritative. The transaction number of the commit is what determines who gets the name. So for example, if I mint my cool container, I make the commit, I can wait a block for confirmation, not reveal that transaction. So no one knows, it just looks like a regular Bitcoin Taproot transaction, right? Well, I can wait for the confirm and then reveal it after. So if anyone's monitoring the mempool, they'll just see the reveal. They won't be able to go back and front run me because I already have the commit burned on chain 1 or 2 commitments before. So they can't actually front run me and take that container name. It's too late. They got to see what I revealed. Well, I'm the first leading candidate, so I get the container name. No one else can because I provably am the first. And so that's why we must wait 3 blocks for the commit, because someone could have minted the same name within that window, and we're just waiting for them to reveal it before us. If they don't reveal, if no one reveals in that window, then this pending candidate becomes the verified container, and it's permanently belongs to the minter. Oh, and here it is what it looks like. It just says, after 3, it says status verified, and then you see this $ container appears now at the top level of Atomical to indicate that it's a container and it's been granted that name. We can see a summary at any time of the command line of the containers we own, summary-containers. You can see here the Atomical number, what container was requested, and the status, and the verified ID, which is the same Atomical. So you can always take inventory of the containers or the collections that you have minted. Okay, let's add new items to container. So we have the standard being used across Ordinals marketplaces. We have edition numbers or identifier, then the ID, it's a metadata. This is just a snippet. This could be hundreds or thousands of entries long. And we just do a yarn cli set, and we use the hashtag myCoolContainer because we already claimed the container. So now we can use, in place of the Atomical ID, we can now use the container name, and the command line knows that we're referring to the container and resolves the Atomical ID underneath. We're just going to add to the items namespace the contents of the file items-sample.json, and we mint it, and it'll be updated just like updating any data on any Atomical. It's just in the container context. We're literally building on everything we've created prior. And finally, we can seal a container permanently. We just use yarn cli seal, and it gives you warnings, and it requires you to type, yes, please seal permanently, or at least it says seal permanently. So, because if you use this, the container is locked forever. It effectively becomes unowned, and the latest snapshot will be there forever, immortalized on Bitcoin. Okay. Here we introduce, shifting gears a bit from NFTs to colored coins. Introducing ARC20, the colored coins that are truly faithful to Satoshi. And we humbly say that if Satoshi were to create colored coins, he would do it this way because 1 Satoshi equals 1 Satoshi. Every token mint is backed exactly by the Satoshi units that represents the total supply, which means the lowest value of any token is exactly 1 Satoshi by definition. We can split and combine UTXOs just like normal Bitcoin. It's like the tokens are hovering on top of the UTXOs, be it taproot addresses or legacy addresses. Any address type carries on the value of the colored coin. We have direct minting and decentralized mint modes. You might recognize the decentralized minting from BRC20, and we're going to talk about that shortly. But first, a token standard would not be complete without a ticker name service. Similar to the fashion of container names, we have globally unique tickers identified by $. First is first. We must use Bitwork, again, to slow down the ticker claims for all the same reasons. And of course, we really probably do want a very nice vanity Atomicals reference or a transaction reference for this, because it's you're making a token, it's going to be that much more special with your own prefix. Ticker examples, of course, anything you can think of, except you can't use hyphens or dashes in the name. They have to be tickers, and they're limited to 21 characters instead of 64. So let's talk about the direct issuance. So a team may want to issue a token directly, traditionally like ERC, Ethereum tokens. They'd issue some supply and then they distribute it to whoever they want in whatever fashion they want. And so that's possible here. We use the mint-ft command. We take the ticker myToke in this case, and we issue a supply of 2,300 units. And that's the number of Satoshis, but the number of units. And hello equals world is the data. Probably we'd use like icon.png or something like that to give you an icon. And then we'd even attach metadata. I haven't shown it here, but you'd want to attach metadata probably about terms and a website if you have one. But we don't do that here. And of course, we have to attach the Bitwork to take the token, and we do. Once we've minted through the process I've already shown before, you can now see that you have the same ticker, $ticker, myTick. It says the ticker candidate. This is a verified and claimed ticker for the current Atomical. And this is a fungible token Atomical with a total supply that's listed, and it's in the direct mint mode. And so we can do balances. Doing a balance, you can see the primary address locally, and we can see here we have the Atomical ID, the confirmed balance. We have a number of UTXOs that sum up to the confirmed balance and the ticker you own. Okay. Now, that was direct issuance, but what about something more, let's say, decentralized? Well, we have that too. Well, the difference is we initialize the fungible token with the init-dft command, the init decentralized fungible token command. We claim a ticker. In this case, the ticker is myDecentral. And we say in the next parameters, it says, for each mint, give out 1,000 units. There's up to 20 mints that are allowed. And minting starts at the block height, in this case, 800,000, 8,100. And some data, hello world, which once again probably would be an icon instead. And we attach some Bitwork because once again, we need to attach some Bitwork to claim a ticker name. And then we've added an optional parameter here called mint Bitwork. This is optional. In BRC20, you can just claim the token units of a mint just by making a transaction. But that's kind of ripe for abuse, and someone could just blast many transactions and pay all the fees and mint a whole bunch of supply for themselves. Instead, what we really want to do is to make the person do work, kind of like how you have to mint Bitcoins themselves. Well, we can force Bitwork to be added to the claim later on, and we can specify the prefix. In this case, it says we must match 4 number 7s in the TXID in order for a person to be able to claim the 1,000 units. Not only do they need to pay the Bitcoin transaction fee, they need to put up 1,000 Satoshis that represent the units of this token, but they also need to expend some energy to prove that they did some work so that they can claim the token. Well, once it's been initialized and you've gone through the 3 confirmations to claim the ticker, well, anyone can now issue the mint-DFT with the ticker name, and a QR code is presented. Once they pay, their local computer will start mining for those 777 prefix to attach the bitwork. And if it's all successful and hasn't been minted out, then the user will receive the tokens that are granted by the protocol for the total supply. And then from then on, the decentralized fungible tokens behave just like the direct issuance, except they were just issued in the decentralized mode. Transfer and split works works just like Bitcoin. So you can have any number of inputs of any colored coin, any fungible token, and you could split them out in any fashion as well, and use the transfer FT command with the ticker. I don't show it here, and it's just kind of the technical detail, but the key is, as long as the output quantity matches the input quantity, like the total value of the incoming total value of the incoming Satoshis equals the total value of outgoing, then all the UTXOs are colored just like Bitcoins. If a mistake is made, yes, the user can burn their own coins if they, for example, try to inflate the supply and create an output that has, say they only had 1,000 units of this token, and they try to create 2,000 units for themselves. Well, that is effectively a burn because it's false. So as long as the output quantity is conserved with the input quantity, all is good, and it works just like Bitcoin. So it sounds scary, but it's not, because it's very easy to actually just ensure that the input and output quantities match, just like Bitcoin itself. And wallets, and we'll build in just the validation to make sure that's done, and so users are not going to accidentally inflate or try to cheat the protocol, which just won't work. And that's why we call it Satoshi Faithful, because it's like the coins hover on top of the UTXO, and they can be split and recombined in any fashion, just like the native UTXO. And so there's really it's like a zero overhead coin, but it has the power of Bitcoin, and backed by Satoshis themselves. We could add decimal placements in the metadata. You could say there's a number of how many decimals, but we just say there's only 1 decimal or 0 decimal places. Another kind of not immediately obvious benefit of this technique of using Satoshis to back the tokens is that, like, scammers that just want to create a token with that have no intention of supporting it or doing anything with it, well, they still need to put up the collateral, right? So in order to mint a token with say 100 million units, that's 1 Bitcoin. They need to actually front up exactly 1 BTC of value to mint that initial coin. And if they're giving this out to people, in airdrops or whatever, they're literally giving away Satoshis and giving away their Bitcoin to the community. And so it kind of increases the requirements of a team to be honest, and also to have collateral up front to be able to mint the token. You can't just create numbers out of thin air and then say they're worth something. No, you actually have to have Satoshi units backing. You can see this as Bitcoin is digital gold, and the digital gold is infused into the token. 1 Satoshi equals 1 Satoshi. Okay, the big picture. We've talked about Atomicals theory, the Bitwork mineable tokens, and the containers we've gone through as well, and of course introduced ARC20, which we're really excited to see what people do with. There's one more thing. The Realm name system. The Realm name system is the first real competitor to the DNS name system that can actually go mainstream. There's no domain suffix. Every name is a top-level realm, or TLR. Globally unique, completely alternate universe to domains. Unstoppable, sovereign, digital identities. The Realm name system is encoded as an atomical NFT using all the familiar rules. It's not DNS. It doesn't have DNS, like, suffixes like .com or .net. It uses the plus to indicate that we're in a completely different universe, a completely different dimension, built from the ground up for the Bitcoin native world. This is your Web3 digital passport powered by Bitcoin. It's digital sovereignty. It allows us to prepare for a post-DNS world. What is decentralization if we all depend on DNS, which is controlled by a handful of organizations from the top that can dictate the terms? DNS is constantly hacked. We can prepare for a world where we don't even need DNS. We're going to start now. It's owned by no one and everyone forever. Everyone is their own registrar, equal playing field. Let's show how we can mint and claim a realm. CLI, mint realm, alpha, and we attach our familiar bitwork to slow down the registrations. That's all we'd have to do. I'm not going to go through the, paying the QR code, but that's all it is for the command to create and claim your own realm. To resolve the data like you do a whois, like a DNS whois query, just go CLI realm info. And we use the plus alpha to get data about it. You don't need the plus in this context, but I've demonstrated the plus is interpreted as a realm, and it can be used as an alias, just like the containers with the hash sign you've seen before instead of the atomical ID, or the $ for the tickers can also be used as aliases. But here we're using the realm identifier of the plus. We get the data back. We can see information about the realm. We can see the minting rules, which, I'm getting ahead of myself here, but we can see the data about the realm. This is a top level realm, the full name, and the candidates that were competing for the realm. Because remember, I mentioned earlier, it's so important that we have front run protection. This is to be a real viable alternative, a competitor to DNS. We can't have a name system where someone could just squat on the mempool, monitor all the name registrations coming through, and snatch up the good names and mine like a block faster, or pay a miner to mine your transaction that takes the name up. We need front run protection, and that's why Atomicals provides this. And this is actually the reason for Atomicals having this method, is so we can protect names and actually move beyond DNS. And this was the key ingredient. So here we can see the information about the TLR, in this case called alpha. There's one other thing. Subrealm minting. We can organize and monetize communities by issuing subrealms under any other realm. Alpha could have alpha.web. Any subrealm can issue any other subrealm as well. This is like subdomains or sub hierarchies on websites if you want to relate them. But we're going from left to right, not like DNS, which is right to left. You can organize your tokens. Say you own alpha, you could have a website at .web, you could have your tokens at .tokens, or even maybe a social profile. Every subrealm also inherits the same features and can issue subrealms after it as well. So imagine you have a top level realm and you want to organize your team. Well, you can have a team page or team realm, and then underneath you could issue sub-realms to your team members or members of your guild or clan or community. You could organize your bitmaps underneath your realms and anything else that you can imagine. Remember, everyone is their own registrar. There are no central parties. The use cases for subrealm minting are boundless, from DAOs to clans, guilds, all kinds of communities, web hosting, social media, authentication, members, loyalty, bitmap hierarchies, and so much more. We can mint subrealms directly. So the owner of a realm or subrealm can just use the mint subrealm command. So in this case, alpha.world, and in this case, we're saying the owner is, you can specify your local wallet. In this case, it's redundant, but I've demonstrated we can we can spend from different wallets. So here we're gonna mint the alpha.world subrealm, and the usual process applies. And when it's all done, the Atomical NFT subrealm is put into the user's wallet. There's just one final thing. Subrealm has automated minting capabilities. So any top realm, TLR, and any subrealm allows offering any subrealm for sale at any price. Uses a pattern, regex matching. Payments can be enforced to one or more addresses. You can set the price for any name underneath. The mint procedure is fully automated. Update or revoke subrealm minting rules at any time. You can open it up and just sell subrealms that begin with the letter A, or a set list of names that are available. You might have a group or a clan that you want to form, and there might only be maybe 100 different characters or roles that you want to make available. Well, you can specify that, each have their own price point, or you can leave it open, and you can disable it later as well. And because we can also seal realms and subrealms like we seal containers, there could be a realm offering or a subrealm mint, and when it's all done, the parent realm could be sealed forever into its global permanent state, and all that remains are the individual members represented by the subrealms. That's called claim subrealm by rule set. And all we got to do first is we do CLI enable subrealms for alpha. We attach the sample rules.json, which is just a file that says for this regex pattern, this is the price, these are the outputs you must pay. Once that's enabled, after a few confirmations, here we go, here's a screenshot. You could see we're basically just using the dynamic data properties of Atomicals. So we can attach data into the subrealm's namespace under a rules variable. There's the pattern you see here. In this case, the pattern is anything that starts with an A, has a certain output requirement. And if that doesn't match, then it falls back to the second rule set at a different price point. So you can have hierarchies of price points. Maybe you want to sell realms that have 5 characters or more are one price point, but anything that's say less than 5 characters would have a different price point. And because you can pay to multiple outputs or expect payments to multiple outputs, you can then offload this to realm registrars and marketplaces, which could set up minting rules and also on the realm owner's behalf, and then attach an output that expects a commission to be paid for them in real time, maybe 5% or whatever for setting it all up, and then that would be automatically enforced. And once again, this is all the decentralized indexer. There's no proprietary backend that's doing this, no authority. This is just the consensus rules of the decentralized indexer that we all agree on, and because we all agree, it all just works. Okay, and that was the minting. So we'd want to mint by the subrealm, but not directly by the parent. Let's say, let me back up for a sec. We can mint, if you own the parent realm, you can issue any subrealm anytime you want, provided you haven't already created a subrealm or someone else hasn't minted that subrealm name. You can go and claim anything because you own the parent. But in this case, if you don't own the parent and you just want to mint according to the rules, then you just make a mint subrealm request, and it'll display, I don't have the slide here, but it'll display in the command line the price and the price and the requirement for that. So if you get the subrealm, if you claim it first, then you're going to make a payment to complete the transaction. If you don't make that payment in say some payment window, then someone else could claim that subrealm. Obviously, you need to make the payment. And I won't talk about that now, but there's a 2-step process. First is to claim the subrealm. The second is to follow up with the payment, because if you don't make the payment in time, then you will forfeit your opportunity to claim the subrealm. So here we see, once we've successfully minted, you can see the subrealm candidates. In this case, this was minted. Here it is. It says, await until the make payment from block height for the payment window to be open with the status of pending awaiting payment. What this is saying is, remember that front running protection I talked about? Well, if you mint a subrealm and someone else had the same subrealm in mind, but they haven't revealed the transaction, And if you made a payment before that person revealed, but then they revealed within that 3-block window, well, then you would have lost your payment, right? It could be a lot of money to try to mint a realm, and then you're out that money. Good luck trying to get that back. So we use a 2-phase or 2-step process with subrealms, where the first is to wait the 3 blocks to ensure that you're the first to complain, to claim that subrealm, but then you have 15 blocks after to make the payment. And that payment window is there so that when you're making the payment, you know that you're the leading candidate, that no one else is going to reveal and rug you out of your money. So you have 15 blocks to make the payment, after which the 15 blocks that your claim is expired, you'd have to do it all again, and someone else can go ahead and claim that subrealm instead. This is the difference with subrealms versus top-level realms and tickers and containers. We have to have this 2-step process, but it works really great, and there's no way to accidentally, with this technique, there's no way to have any problems. That's why we did it this way. And that's the make subrealm payment. So we can query on the command line with the CLI pending -subrealms, and we get the information of the local user's wallet of which subrealms are pending awaiting payment. Gives all the information, at what block height you should make the payment from, and the payment is due no later than 15 blocks later. And so it gives you all the details. But with this command line tool, you can just enter the number you want to pay, and then a QR code is presented. And once the payment is made, then it's all automated. So you don't have to do anything manually. So that's how payment would work from the command line. Once claimed, subrealms are your property and can be bought and sold just like any Atomical NFT. Use subrealms exactly like top realms to host websites, files, and links. You can use the / to indicate namespaces or specific files. You can even directly create the subrealms or enable automated subrealm mint rules according to any pattern and price point you want. It's your property after all, and no one can take it from you. Join us in organizing digital matter and decentralized everything. Atomicals and Realms launch will be activated on block height 80, 80, 80, or a little under 2 days from now. Activation is from Atomical number 0. It's approximately 1 p.m. UTC this Sunday. Join us at ground 0. Run an indexer. Check out the command line utility. We'd love to hear your feedback. We need your help. A lot of these resources are not yet written. We appreciate your patience. We're going to be putting these together in the next couple days to prepare for the launch. We have a public server up, and we're going to provide snapshots as well as provide help for people to run their own indexers so they're able to get in on the ground floor and help us launch the Atomicals era and organize digital matter with us. Thank you so much.